Hi, my name's Nick Heaton. I'm a distinguished engineer with Cadence Systems and Verification Group, particularly working on ARM solutions. So today we're going to be looking briefly at some of the challenges we have when we integrate high-speed I/O into ARM server SoCs. I've drawn a block diagram here, a very rough block diagram of a typical ARM server SoC. We've got 4 clusters of processors. We've got an interconnect. We have cache in all of these different blocks. And we have some Cadence DDR IP and PHY interfaces to real memory modules. And the thing I'm going to focus on today is really some of the challenges with integrating PCI Express into a system like this, and why it's a kind of tough challenge to address. Typically in an ARM server we have some external PCI Express devices. So here I've drawn a couple of 25 gig Ethernet. We could have storage or other kinds of devices, accelerators, anything out here. And when we integrate the PCI Express IP, this block here, into the system, it's very interesting because in Gen 4 we have some very big additional challenges that have not existed before. And these are to do with a couple of components here called the system MMU and the generic interrupt controller. The interrupt controller is distributed, so we have pieces of it here and pieces of it here, and the system MMU also communicates with the MMUs inside the ARM processors here. So inside here there's an MMU, and these all need to be kept in sync. Now, why is this important? Well, when traffic comes from the Ethernet interface example, it can come in here and it may have some interaction with the MMU. It may also have an interaction with the interrupt controller. So there is other byproducts of these interactions, and setting up your system to actually allow you to test this is really quite complicated, because we need to have had all of these components set up with software. Now, one of the challenges here is this is a very complicated task when there is no operating system, and this is where we call this bare metal testing. And one of the things we've been working on is portable stimulus, where we can deliver stimulus ready-made to help you integrate and address some of these challenges. The benefit of that is that you focus on the things that are unique for your SoC, and in that way you get to tape out quicker. So the whole purpose of EDA is to bring in the time frames. This is a particular challenge we've been working hard to address in Cadence. Thanks for listening. Tune in next week for another topic.